Okay, part D now, the question is about the project completion between two durations. Okay, so I will always start by that. X is the duration of the critical path and the same, so which allows me now to write the original question in terms of X. Okay, so I need the project to be completed between 14 and 17 weeks. Let's see at the, so here we go in terms of X. So this is the probability that X is between 14 and 17. I'm sure that you are familiar how we came out with that from the original question. Okay, so on the curve, where do we see that probability on the curve? Remember, probability is area, so where is that area under the curve? We are looking for the area between x equal 14 and 17. So here we go, this is 17 and this is 14, so we're looking for that area. All right, this is the blue area. This is what we are looking for. This is our final answer. What do we notice about this area? This area is equal to all that area, which is the probability that x is less or equal than 17. It's all that. So from this cutoff point until the lower tail, and then I can subtract this. First, this I will call it A1, the red area, which is the cumulative area from the lower tail until x equals 17. And then I subtract the smaller area, which is here, right? Then I will end up with the one in the middle, okay, which is not A1. A1 is the cumulative one, all the red one. So this one, the black one, I will call it A2. So which means now my probability, it's equal to A2 minus A1, right? Which is what it's equal to. The red area, A1, was representing the probability that x is less or equal than 17. So all the cumulative area under the curve from the lower tail until 17. And I'm subtracting the smaller area, which is A2. Now we learned how to do that from previous two slides. If I want to find the area for a certain x, then I find the value of z corresponding to this x, and I will find the corresponding z for that one. So let's do this. So I will find A1 as P of z less or equal than z17, which is 0.8413. We found it in the previous slides. And A2, we can get it from z14. All right, also you find that z14 equal 14 minus mu over sigma, and you find it to be minus 2, and this is how we found that one. I don't need to repeat it again because we did it before. So the difference between these two areas give me the probability that x is between 14 and 17, and this is equal to 81.85%. And this is our final answer. This is the probability that the project is completed between these two times, right? So I hope that was clear for you. Please try to do it on your own. Okay, we come now to the last question, which is honestly my favorite question in this example. For one reason is that it requires more understanding for the use of statistics here. So here the project manager is wondering what would it be the duration within which he can be 80% confident that he can finish the project. I like this question mainly also because it reflects some practical applications, right? Any company has a certain risk management policy, and for example, this question can reflect that this company can take up to 80% risk. So that's why the manager wants to know what should be his committed duration, right? And if he's 80% confident that he can do it within the committed time, that's it. He's not taking risk more than that, and he's taking a risk of 20%. So this is really a very, very good question. So what are we looking for here? Okay, let me get my pen. Okay, so on the curve, okay, we are looking for a value of x that we don't know. I'm going to call it x star, okay? So critical value of x, it's not known for us, but what's known is the area below that. So I can write P of x less or equal than this critical value is 80%. As we did also in the previous questions, we will always refer to the z table. But now, instead of referring to the z table to find the area, we are referring to the z table to find the z itself. How? We're going to also project this x into a z table. So the corresponding value of z is called the z critical that we are looking for. And once we find that, we can find x star. And what do we know about the z star? Because we are saying that this z star corresponds to that x star, and that x star has an 80% probability below it, so that area is also 80%. Which means what? Which means P of z less or equal than z star is 80%. So the question is, what is that value of z such that P of z less than it is 80%? So I take an extract from the z table, and I look now inside, right? Inside the area for 0.8. And we search for, you don't necessarily always that you find exactly the same value, but you try to find a value that is as close as possible. And I believe this value is the closest to 0.8. So it's 0.7995. So what can I write about that? Look at this. The corresponding value for that is 0.8, but it has another decimal, 4. So 0.84, right? So I can write that from the table. It shows me that P of z less or equal than 0.84, right? 0.84 is 0.7995, which is very close to my 0.8. Okay, so now I say that z star is 0.84. And I'm going to use my famous now conversion equation between z and x. And I can write z star is x star minus mu over sigma, where mu and sigma are the parameters of the x distribution. And then I substitute z star with 0.84 and mu is 16, standard deviation with 1, and I can solve for x star. And here we go. That's our final answer. So we can say to the project manager, you can be 80% confident that you can finish your project within 16.84 weeks. Okay, so that was all. Thank you for listening, watching these videos. I hope that they were useful. I hope that they will help you to learn. This is a very, very important topic. Hopefully you can do similar problems on your own. Thank you.